Hey everyone, it's ZyXEL here, and today I'm going to teach you how to do network address translation on your ZyXEL ZyWALL USG20. Now, before we actually do anything, we have to somewhat understand what we're translating. So I'm going to draw a simple picture of what we're going to do. So, let's assume that we have something like AT&T Uverse for our internet. And let's let this blue circle represent our AT&T router slash modem slash wireless access point, the all-in-one device they give you. And let's say that there's a line connecting these devices. This will be our RJ45 Ethernet cable. And this will be connecting to our ZyWALL USG20 firewall. And let's change that back to a circle. And it doesn't have to be a purple circle. Okay. Let's assume this red thing, like I said, is our firewall. And now, let's add an end device. Like a computer, for instance. And our green circle is going to represent our computer. Okay. Now, here comes the interesting part, which is the network address translation and why it's necessary to do this in certain cases. Let's assume that we've got some random IP, and let's move this text back down to 12 or so. We can make it a little bigger. How about 18? Okay. Let's assume our public IP address is something like, I don't know, 5.29.32.45. It doesn't really matter. This is just an example, okay? So let's assume that this IP address is our public IP address and it's connected to this particular end of our AT&T all-in-one device. Now, our AT&T all-in-one device here has a network address translation to translate that number right there into something a little more usable, like a private IP address such as 192.168.1.x. Because we're assuming DHCP is available. And let's just change these over to green so it's a little easier. Alright. So with that being right there, we're going to assume that on this end, on this connection right here, anything connected to it is going to get an IP address somewhere in the range of 192.168.1.1 through 192.168.1.254. So anything can be there. So now we're going to kind of figure out what we're going to do with this. This connection where the ZyWALL is being plugged into, our WAN port specifically, can be anything that the DHCP on the AT&T modem wants it to be. But let's assume it's something like 192.168.1.60. It could be anything within the range I previously stated, but let's just assume it's something like that. So we're going to put that there. And now we're going to assume that it belongs to this part right here of the ZyWALL, which is our WAN connection. And that's fine and dandy. But the problem is, our ZyWALL, our USG20, is acting as a router by default. And it wants to give DHCP services to anything connected to it. So we cannot have the connection from here. This is a poorly drawn arrow, but we can't have any connection from here to, let's say, our end device, since we've only got one. Anything from here to here cannot be on the same network as these connections over here. Otherwise, we have conflicting double NAT issues. So there's a very simple way to fix this. In order to fix this, we have to make sure the connection on this end, anything connecting to the ZyWALL's other 4 ports, its switch ports, has to be on a different network. So we're going to just simply make it 192.168.2.x. And by doing this, we put it on a different network so that there's not a double NAT conflicting issue. And we're going to say that that particular thing happens to anything connected to that port on the ZyWALL. And to make this a little more simple to understand, we're going to assign this computer, this end device, a 192.168.2.5 address. So, as you can tell, it's not on a .1 address, it's on the .2 address, because we're assuming that this particular computer got its IP addressing information from the DHCP server that has been set up on our ZyWALL. And since we have our ZyWALL to give a .2 addressing scheme to any end device connected to that port, this in return will also have a .2 address. Now this is all fine and dandy. This helps defeat that double NAT issue we're having, so that this end device can go all the way and ping this AT&T router through the ZyWALL. But we have an issue. We've got an incoming transmission, let's say we're hosting a server, coming from this address, translated into the .1, and now we need to translate it from the .1 to the .2. So now we're going to try and figure out how to do that. And it's actually a lot more simple than you might think. Now there's a few different types of NATs we can do. For this situation, we're going to go with what we call a 1-to-1 NAT. And what that means is we're going to take an address from over here in the .1 domain and translate it to the .2 domain. This address that we're going to be translating exists somewhere, but isn't necessarily used. So what we're going to do is, while we're doing the NAT, and this is how it breaks down, I'll show you how to do it in the firewall, but this is basically what happens. We want basically 192.168.1.5 to translate into 192.168.2.5. So basically, we are taking some sort of IP from this range right here, which, like I said, it exists somewhere in there because X is our variable. This connection supports anything from 192.168.1.1 to 192.168.1.254. So we've got a wide list of, or wide range of addresses we can use. We're just specifically using the ZyWALL, the ZyXEL USG20, to take whatever one of the addresses from in there and tell it to translate it to whatever address we want it to over on this network, so that it can get from one end to the other. So essentially, what we are doing with a 1-to-1 NAT is taking 192.168.1.5, because that's specifically the one we want, and we're translating that over to 192.168.2.5. And that is what our 1-to-1 NAT does. It's taking some IP from the .1 range and translating it to a single IP in the .2 range. This is very handy because without doing this, you start getting issues. Now, it doesn't have to simply be a one-to-one NAT. What it could be is what we call a one-to-many NATs, or sometimes called a one-to-overload. Now, what this means is we can take a particular range of IPs from this section, from this subnet range, and translate it to a range of IPs available in this subnet. So basically, we can do something like this: 192.168.1.5 through 192.168.1.50, for example. It doesn't have to be that particular range, but it's just an example. You can use whatever range you really want. And we're going to use that range, and we're going to translate that over, and let me draw a little arrow here so that we can kind of keep up with where I'm going with this here. We're going to translate that range into a range that we specify, which in this case, if we want to make it nice and even, it's going to be 192.168.2.5 through 192.168.2.50. And this is what our one-to-many or one-to-overload NAT does. It allows us to translate automatically any of the IP addresses within the ranges we specified. So now that we've got a basic idea of what NAT is going to do, you need to kind of figure out what kind of NAT you want to use. If you're expecting many devices to connect to your network on and off, you might want to do one-to-many or one-to-overload and set the range to whatever you have your DHCP lease range to be. This will make it so that any device that connects via DHCP automatically gets their NAT translated correctly. Okay, so now assuming that you've logged into your firewall's web GUI, we're going to have to make sure you've set a few things correctly to make the situation that we talked about before work right. Now remember that in this diagram, we're translating from 192.168.1.x to 192.168.2.x. So to make sure that the devices we have connected to it are on the right subnet, we need to go to the interfaces here. Now LAN 1, LAN 2, and all that stuff should basically mean, if you have it all stock settings, LAN 1 is the 192.168.1.1, and the 192.168.1.x, which you don't want because then you get the double NAT issue. If you go to LAN 2, anything connected to the port configured to LAN 2 will be 192.168.2.x. So basically, that setting applies to this section right here. Alright? And since this side is already the .1 area, we need this to be a different area. So that's why we're choosing .2 in the configuration over here. These are the ports that your end devices connect into. So assuming we've got it on LAN 2, you should be good for this step. Next step is actually configuring the NATs. Now, I've already got some NAT configurations done. As you can see, I've got one-to-one NATs and many-to-one NATs. So this is what we were talking about before. We've got our ranges and everything. Now, I'm just going to make a random NAT configuration that won't actually provide me any useful any use, but it'll give you a good idea how to do it. So let's make a one-to-one NAT. We're going to click Add. And we're not going to enable this rule. Well, not for me at least. And we're going to just name this test. You can name it whatever you want. And notice there's three options. There's virtual server, but we don't really want that right now. We're going to do one-to-one NAT. Now, our incoming interface. This basically means where is the original network address range you're translating coming from. In our case, it's connected to our WAN. This right here is going to be our WAN section, and it's connected to the .1 interface subnet range. So that's what it's asking for in this particular situation that we've got set up here. So we're going to select WAN, and like I said, that's going to be our .1 subnet range. Our original IP, user defined. Now, we're going to keep it at user defined. You can make an object that's already defined, which to do that we would go create address, and basically if we were to make like some random thing like custom PC, for example, that would be an actual device connected to your network, and you would give it an IP address, and basically you would select that. Like if I were to do Xbox, all those things went away because we've already previously defined what the Xbox IP address is. But that's not what we need to focus on right now unless you want to do it like that. So we're going to go back to user defined. So our original IP address, what is it starting as? It's somewhere in the .1 subnet range. So let's assume we're just going to take any particular IP. Let's say it's 192.168.1. I don't know, 5, like we were originally talking about in here. So let's pretend it's that. And mapped IP. This is the IP we're translating it to. So let's say it's 192.168.2.5. Now, port mapping type. If you only want the particular end device to be functional with a certain port, you would type in port, the original port, and the mapped port. It kind of works the same way with the IPs. If you had an original port of, let's say, like 2000 and you wanted to translate it to like 5000, that's how you would do it. And you would specify a protocol and all that. You can also specify a service. But for this particular case, we're assuming that it's just a computer and you just want it to work right, and that you want any port that it's required to use to get there. So this is how you would configure it. All right? And then you would click OK. Now it is in your NAT configuration rules list. Now notice I don't have it enabled. Only the things with the little yellow light bulbs are enabled. That is a one-to-one NAT. And notice it says everything here. We named it test, that's our rule. It's a one-to-one NAT. Our incoming interface is our WAN port. Our original IP, 192.168.1.5, has now been translated into 192.168.2.5, and we allow any protocol and whatever ports necessary. We can configure port forwarding or port opening, whatever it wanted to be in the firewall, but we're not worried about that right now. So that's our one-to-one NAT. Now let's say we wanted to make a one-to-many NAT. We would go to Add. We would select Many one-to-one NAT. Our incoming interface is once again our WAN port. And as far as this, I'm not going to enable the rule because I don't want it right now because this is just an example. We'll name it test 2. Now, original IP subnet range. Notice it's not as simple as just typing it in. You actually have to select an object that we've made. In order to do this, we create new object, address, name, and we'll just call it test_range. And we want to select range under the address type. And this is where you type in the range. So let's assume it's 192.168.1.1 through 192.168.1.250. And that gives us our starting IP and our end IP address range. Any IP from this one to this one will be in this range. So now that we've made that, we want to select our original IP subnet range, which we've already defined, and it says in here what it is. And now we're going to define our mapped, our translated range. So we go back to our create new object, and you test, what did we call the first one? Test range 2. And we are going to once again select range. Now we want this to be nice and even. So we're going to go the same thing we just did before, only in the .2 domain range. 192.168.2.1 through 192.168.2.250. And we're going to click OK. Into our mapped range, we are now going to select our test range, our translated range. So you can see here that we've just translated all those IPs in that range over to a 1-to-1 ratio of all the IPs in our .2 range. Now we click OK. And assuming it's enabled, which it's not for me because I don't want this as an example, now any computer with an IP address from this range, 192.168.2.1 through 192.168.2.250, is going to be translated, or I'm sorry, they're going to be translated between these ranges, okay? Just keep it at that. Pretty simple. It's just like the 1-to-1, only now we've got ranges set so that any IP within that range gets translated correctly. And that is how you do a network address translation in the ZyXEL ZyWALL USG20 using either 1-to-1 or many 1-to-1. So looking at all this, we've just configured it in the firewall. If we go back to our little chart here, it kind of makes sense now, doesn't it? We just took a bunch of addresses from the .1 range, translated them over to the .2 range, allowing any of those addresses connected to this within that range to be translated correctly over to this, and now our AT&T device is going to translate back and forth between these IPs so that anything you do gets out to the internet and comes into you from the internet correctly. And that's pretty much it. Hope you guys enjoyed the little tutorial, and thanks for watching.